All right, section 11.4, inscribed angles. Today's objectives. I can find the measure of an inscribed angle, and I can use inscribed angles and their properties to solve problems. We have to figure out what an inscribed angle is first. We'll also talk about an intercepted arc and what it means to subtend something. So here are those three vocab words. Okay, first we've got an inscribed angle. It's an angle whose vertex is on a circle and whose sides contain chords of the circle. So you see DEF is an inscribed circle. So basically what we're talking about is we have the vertex on the circle. Okay, vertex on the circle, and these are chords of the circle as well. An intercepted arc is the arc that's formed by the angle. Okay, so the arc DF would be an intercepted arc. We also say that anything that has endpoints where those chords meet the circle, it's called subtending. So this arc subtends it. We could also say that the chord DF subtends the angle. Okay, so subtends just means it's got the same endpoints as those angles there. All right, so our first theorem here, inscribed angle theorem. If we have an inscribed angle, the measure of that angle is half the measure of the intercepted arc. Okay, it's pretty basic once you get to see it. And all three of these are examples here. All three are cases. You'll notice that one of them, case one, we have one side is a diameter. It doesn't have to be a diameter. What has to be true though, and you'll see it in all three of these, is that the vertex has to be on the circle. If the vertex is on the circle, this is the case that we're talking about. Previously we talked about when the vertex was the center of the circle, it was equal to the arc length. That's not the case anymore. Okay, now we're looking at if it is on the circle. Okay, if the vertex is on the circle, then that angle is equal to half of the arc. And we'll take a look at that in a second here. Alright, so here's our example. We're looking for the measure of PRU. Okay, looking for the measure of PRU. And what our theorem told us, if we have an inscribed angle, that angle measure is half of the arc. So if the arc is 118, the angle measure is simply half of that. So the angle measure would be 59 degrees. And we see that here. Half of that angle is 59 degrees. When we look at this one, now it's the opposite. They give us the angle measure, they gave us the angle PRS, and we're looking for the measure of the arc SP. Well, we know it's the opposite. So if the arc is half, or sorry, if the angle is half of the arc, that means if the angle is 27, the arc has to be 54. Okay, and they're gonna, set up an equation and solve it and do all that. We just know that the angle is half of the arc. Okay, that's the most important part here for inscribed angles. If we have an inscribed angle, and remember that's the vertex is on the circle, the angle is half of the arc, which means the arc is twice the angle. Okay, we have to be able to go both ways with it. Okay, so if we look at this one, the measure of ADC, when we first look at this, it might look a little confusing, because you're looking at this whole big arc here, and so you're thinking, well, how am I going to figure out this? Is that 180 degrees? We don't know if this is a diameter, right? We don't know any of that. What we do know here is that we have angle ABC. Okay, it kind of gets lost down here. But we've got angle ABC, which is 135, which means it opens up to an arc that's twice that amount. So that ADC there, that big arc, that subtends that angle. If it subtends that angle, it's twice that angle. So instead of 135, we know that that arc is going to be 270 degrees. Okay, look at this one. Think about measure of angle 8, measure DAE. DAE, we see the arc is 76, so we know the angle has to be half of that. So our angle, of course, is 38 degrees. All right, our corollary to this. If inscribed angles intercept the same arc or are subtended by the same arc or chord, then the angles are congruent. So if they both open up to the same arc, then those angles are congruent. So you'll see that the angle ACB, ADB, and AEB all open up, are all subtended by arc AB. Since they're all subtended by the same arc, that means all three of those angles are congruent. Okay, so that's going to help us moving forward. You'll see that it also says and CAE and CBE are congruent. Well, CAE opens up to CE, and CBE opens up to CE. Okay, the arc CE subtends both of them. So, it's really going to have to be paying attention and looking at what do they open up to. If they both open up and are both subtended by the same arc, then they are congruent. So if we look at this, I want you to look and I want you to think about it. Find measure ABD, okay? And then I want you to find the measure of the arc BC. So measure of ABD, the angle, ABD is right here. That is subtended by the arc that's 86 degrees. So my angle is half of that. My angle is 43. And then if I'm looking for the measure of the arc BC, well, the arc BC here is subtending the 60-degree angle, so it's double that, so we know it's 120 degrees. Our next theorem, if an inscribed angle subtends a semicircle, then it is a right angle. And it's an if and only if, so it's a biconditional here. But if we have this situation where we have an inscribed angle where it's a right angle, it has to open up to 180 degrees. We know that because the subtended arc has to be twice that angle. So if it's a 90-degree angle, it has to be a 180-degree arc. The only way we have that is if we have a diameter. Okay? And vice versa. If we have that diameter that is subtending our angle, then the angle has to be half of that. So 180 degrees, half that is 90. So we want to find A in this problem, and what we know is that it's subtended by this half circle. We have WY as a diameter, which means if that's a diameter, 180 degrees here, this angle has to be a right angle. So we can simply set up 5A plus 20 is equal to 90, and we can solve it. That means 5A is equal to 70, divide by 5, and we're going to get 14 as our answer for A. Okay, let's look at this one. We're looking at LJM is what we want, LJM. Well, it's not a right angle, right, because it's not subtended by a diameter. But what we can see here, and this is the theorem that we talked about before, we didn't really do anything with it at the time, is both of these angles, they are both subtended by this arc, LM. Okay, they both open up to that arc. Since they both open up to that arc, they're both inscribed angles, that means these two things have to be equal to each other. They're congruent. So we're going to set them equal to each other. We're going to substitute in. We're going to solve it all out. B is equal to 3.5. We can plug that back in, and we know LJM is going to be a 10.5 degree angle. Okay, I want you to try it, see what you can get. All right, of course, we're setting it equal to 90. We're solving it, and we're going to get our answer of 12. How about this one? Try it out. We're looking for EDF. Of course, these are both subtended by the arc EF. Okay, so if they both open up to the same thing, we can set them equal to each other. If we set them equal to each other, we're going to get x is 18, plug it back in, we get 39 degrees. Our last theorem here, if a quadrilateral is inscribed in a circle, and it's inscribed if all four vertices touch that circle, are on the circle, then the opposite angles are supplementary. So that means A and C are supplementary, B and D are supplementary. So anytime you see this figure, this is going to happen. So let's talk about why this is the case. Well, what we know is that this angle right here, ABC, is subtended by this arc, AC. Okay, well, we've got that. This angle right here, ADC, is subtended by this arc, AC, both ACs. Well, what we have in total is 360 degrees there. And so the arcs, when I add the arcs together, I get 360 degrees. We know that the angles are half of the arcs. If the arcs add up to 360, then the angles have to add up to 180, which of course means they are supplementary. So here we go. If we want to find the value of B, we need to figure out what we can do. We've got three different values here that we know, and overall we're trying to find the angle measures of all four angles. We don't know necessarily that kg is a diameter, so you can't assume that unless they tell you, unless they put that center in the middle there. But what we do know is that it's quadrilateral that's inscribed. Since it's a quadrilateral that's inscribed, we know that these two, the opposite angles, are going to be supplementary. So I can add those together, set it equal to 180, and go from there. So you kind of see here, I add those together, set it equal to 180, I solve it all out, I get B is equal to 15. Well, once B is 15, then I can plug it back in. I can plug it back in really to all of these. So that's going to give me 70, 110, and 81. And then for angle H, I know that's just supplementary with angle K. So whatever K is, in this case 81, I can subtract that from 180. I know angle H has to be 99. So by just setting those two equal to each other, G and J, I can figure out what B is, and I can solve all four of these angle measures. Okay, I want you to try it out. A little bit trickier with a 9 halves x here, but figure out what you're setting equal to each other, solve for x, plug it back in, go through the whole thing. All right, so if we take a look, we set up the 4x minus 13 plus 33 plus 6x equals 180. We solve it out. We figure out that x is 16. We can plug 16 back in for x. That's going to find us our three angle measures, MK and L, and then we can subtract that one from 360, and we're going to get 108 left over for that. Okay, lesson quiz. I want you to pause it, try it, come on back. All right, RUS. We know RUS is going to be half of that intercepted arc, so that's 25 degrees. And then when we're solving for A, we know that it's subtended by the semicircle. So if it's subtended by the semicircle, that means the angle is 90. So we can set that equal to 90, solve it out, we get A is 3. All right, we're going to skip number 3. For now, we don't need to worry about number 3. Let's look at number 4. I want you to try number 4 and come on back, see what you get. All right, so we can of course set the two opposite angles equal to each other. We know that they are supplementary. You end up with A is 95, D is 95, and then B and C are both 85. So there you go with 11.4 inscribed angles. The thing to remember is that the inscribed angle is going to be equal to half of the intercepted arc. Okay, intercepted arc is going to be twice that inscribed angle. There you go. Hopefully you've got it. If you need to, watch it again, take some notes, try out the practice problems, and you should be good to go on 11.4.